Welcome to our essential training video on cybersecurity tools. Whether you are new to security or just seeking to understand the core defense mechanisms, this course is for you. We will break down the complex world of security tooling, starting from basic device protection and moving through advanced cloud platforms and automation technologies. Tools are absolutely critical because they help automate security tasks, detect threats, and drastically reduce the risk caused by human error. Let's start with the fundamental goal of security tools: protecting your organization's digital environment. Security tools are fundamentally designed to help protect your systems and data, minimizing mistakes often made by people, which is a common cause of breaches. However, since no single tool fits every situation, the right choice must align perfectly with your specific security needs, risk profile, and environment. We start with two basic, yet powerful tools. The Next Generation Firewall, or NGFW, is like a highly intelligent gatekeeper for your network, inspecting all traffic to block malicious data, rather than just blocking standard ports. Meanwhile, the Endpoint Protection Platform, or EPP, acts as the first line of defense installed directly on devices like laptops, actively working to prevent known threats such as traditional malware and viruses from ever causing harm. Together, these tools establish robust initial defenses for your network edge and individual user devices. This diagram illustrates the two main foundational tool categories. On the left side, we see perimeter security, represented by the Next Generation Firewall, which focuses on advanced techniques like deep packet inspection and application awareness to secure the network edge. On the right, we highlight device protection, provided by the Endpoint Protection Platform, which is focused on initial defense measures such as antivirus and blocking known threats directly on the user device. The ultimate goal, connecting to both branches, is to reduce human error and ensure that tool selection matches the unique requirements of the organization. This foundational layer sets the stage for more advanced security strategies we will explore next, such as dedicated detection and response capabilities. Building upon the basic prevention provided by the Endpoint Protection Platform, we introduce Endpoint Detection and Response, or EDR. EPP is like a strong lock on the door, focusing mainly on stopping known threats before entry. In contrast, EDR is a complete internal surveillance system that watches everything happening on the device, gathering massive amounts of detailed information known as telemetry in real time. This deep visibility allows EDR to catch sophisticated, previously unknown threats, such as zero-day attacks, that traditional prevention tools cannot identify. Crucially, EDR doesn't just detect. It also enables security teams to perform detailed forensic investigations, understand the entire scope of an attack, and execute automated actions, like isolating an infected device from the network to stop the threat from spreading immediately. This flowchart demonstrates the relationship and functional progression, from basic endpoint protection to advanced detection and response. The endpoint first encounters the EPP, which tries to prevent known threats, blocking and quarantining them if successful. However, if an unknown or sophisticated threat bypasses the EPP, the EDR system takes over, initiating continuous monitoring and collecting deep telemetry data. This data is then analyzed for abnormal behavior and anomalies, leading to the detection of advanced threats like persistent threats or 0 days. The final step shows the capability for automated response and forensic investigation, highlighting EDR's role in mitigating and analyzing complex security incidents that the EPP alone cannot handle. This shows how prevention and detection work together for comprehensive endpoint security. As organizations shift their applications and data to the cloud, specialized tools are required to secure these flexible new environments. Cloud Security Posture Management, or CSPM, is vital for ensuring your cloud architecture is set up correctly. It constantly scans your infrastructure, checking components like network settings and virtual machines against security benchmarks to catch dangerous misconfigurations. If CSPM is about the foundation, Data Security Posture Management, or DSPM, is about the jewels stored inside. DSPM locates, categorizes, and protects sensitive data, such as customer records, regardless of where it is stored in the cloud. It is particularly useful for detecting shadow data, unauthorized sensitive information, and confirming adherence to privacy laws like GDPR or HIPAA. This class diagram distinguishes between the two specialized forms of cloud security posture management. The Cloud Security Tools class is the general concept, which branches into two specialized roles, CSPM and DSPM. CSPM focuses on the cloud infrastructure, with primary functions being scanning configurations and monitoring overall compliance against established policies. DSPM, on the other hand, centers entirely on data assets, managing tasks like discovering, classifying, and governing sensitive data. While both are critical specialized tools, the arrow pointing from CSPM to DSPM suggests that secure infrastructure configurations provide necessary context for effective data governance. Understanding these distinctions is crucial before moving on to the broader unified platforms. Historically, security teams used many separate specialized tools, leading to, quote, tool sprawl and visibility gaps. To fix this, the industry introduced the Cloud Native Application Protection Platform, or CNAPP. CNAPP is a unified solution designed to protect modern cloud applications across their entire lifecycle, from the moment code is written all the way through to when it is running live. Instead of juggling various products, CNAPP integrates key functions like CSPM for configuration checks and CWPP for real-time workload protection, along with other critical security capabilities. CWPP is particularly important because it secures the dynamic, short-lived components of cloud applications, like containers and serverless functions, ensuring they are protected during the most vulnerable runtime stage. This diagram maps the CNAPP concept against the application lifecycle. The lifecycle starts with code and build stages, moving through the automated pipeline to finally reach the cloud runtime environment. The CNAPP acts as the unified security layer, collecting insights from various integrated security disciplines. We see three key inputs converging into the CNAPP. CSPM handles configuration posture, CWPP manages runtime workload protection for containers and virtual machines, and code security handles scanning early in the cycle, which is also known as shift-left security. By consolidating these areas, the CNAPP provides holistic, end-to-end visibility across the entire cloud application environment, addressing the fragmentation challenge of using separate tools. Moving from securing cloud applications, let's look at how we secure the connection between users and those applications, especially with remote work becoming common. The solution is Secure Access Service Edge, or SASE, which simplifies security by combining network capabilities and comprehensive security functions into a single service delivered entirely from the cloud. SASE removes the reliance on old, complex physical hardware at every location. Critical security tools delivered through SASE include Firewall as a Service, which is essentially a cloud-native firewall, and the Secure Web Gateway, which filters malicious web traffic. Central to SASE is Zero Trust Network Access, or ZTNA. ZTNA ensures that no user or device is trusted by default, strictly verifying their identity and device health before granting the absolute minimum access required for their task, known as least privileged access. This network diagram illustrates the SASE cloud architecture and its key security functions for remote users. Individual users and branch offices connect via the internet directly to the SASE platform, which is delivered as a cloud service. Inside the platform, several functions work together. ZTNA verifies the user and device, ensuring that only authenticated users receive least privileged access. FWaaS inspects all the data traffic, acting as a powerful cloud firewall. SWG filters web threats to ensure safe application access, protecting both the corporate data center and cloud resources. This model simplifies management by consolidating these critical network and security tools into one cloud-delivered service, providing consistent protection regardless of the user's location or device. To manage the high volume of security alerts efficiently, security teams rely on automation tools, known collectively as SOAR, or Security Orchestration, Automation, and Response. SOAR platforms allow teams to define specific automated workflows for handling security incidents, significantly reducing the reliance on manual human intervention during repetitive tasks. These workflows are built using playbooks, which are essentially fully documented, step-by-step security procedures. When an event triggers an issue, a playbook queries and analyzes data, and then decides on the correct course of action, often executing specific actions automatically. Playbooks are highly flexible, built using individual tasks, custom scripts, and integrations that connect to various security tools to ensure a consistent, rapid, and tailored response to every incident. This sequence diagram illustrates the automated workflow managed by a SOAR playbook during an incident. The process begins when a threat actor initiates an attack, causing the endpoint protection system to send an alert and telemetry data to the central data lake, often managed by a SIEM system. This alert immediately triggers a new incident case within the SOAR platform, initiating the automated playbook execution. The playbook first performs an enrichment step, gathering more context, and then automatically instructs an external action tool, such as a firewall or identity manager, to contain the threat, for instance, by isolating the compromised endpoint. Finally, the playbook handles non-technical tasks like reporting and ticketing. This automation drastically speeds up response time and ensures every incident follows a precise, predefined procedure. Automation relies on high-quality data and deep intelligence, which leads us to Security Information and Event Management, or SIEM. The SIEM acts as the central brain of security operations, collecting millions of security logs and events from every part of the network, including endpoints and firewalls. Its key function is to analyze and correlate this massive stream of data in real time, turning isolated events into actionable, high-priority security alerts. To effectively hunt for threats within this ocean of data, security teams use specialized query languages. For example, Cortex Query Language, or XQL, allows analysts to quickly write powerful searches to query large datasets, filter irrelevant information, and find hidden attack patterns that traditional systems might miss. This combination of centralized data and rapid analysis is crucial for proactive defense. This diagram illustrates the flow of data used for advanced threat analysis. We begin with the three main data sources: logs from endpoints, traffic data from firewalls, and audit records from cloud providers. This data flows through a centralized ingestion process and is stored in the data lake, which is often a CM system. The analytics and correlation engine processes this centralized data, looking for patterns and linking related events. The XQL query language acts as the primary tool used by analysts to interrogate this engine, allowing them to perform deep, specific searches. Successful searches generate threat hunt findings, which are then converted into actionable threat intelligence. This process ensures that security teams can quickly analyze large datasets to proactively discover and respond to threats using highly specific queries. Bringing all our learned concepts together, we arrive at the unified security platform model, represented by Extended Detection and Response, or XDR. XDR represents a significant shift by connecting data from endpoints, networks, and cloud environments to give security teams a holistic view of an entire attack across all domains. This unified vision moves past the traditional strategy of using many separate tools, simplifying operations and improving security efficacy. Advanced versions, such as Cortex XSIAM, take this consolidation even further by centralizing key security functions, including XDR, CM, and SOAR, into a single, comprehensive platform. XSIAM leverages powerful artificial intelligence and machine learning to analyze the vast data foundation, proactively detecting threats and automating complex responses, transforming security operations to effectively stop threats at scale.